Hello everyone, welcome to our new video. In this video, we are going to discuss some Java programs that are based on loops. So let's start the video. Our first program. Write a Java program to check whether a number is palindrome or not. So what is a palindrome number? A number is said to be a palindrome if it remains same when the digits are reversed. For example, suppose we have taken here a number 12421. If we reverse them, the number will be same as that of the previous one. It remains 12421. So this kinds of number is called or known as a palindrome number. So we are going to write a Java program that accepts a number from the user, and it checks whether the accepted number is a palindrome number or not, and according to this it displays the message whether it's a palindrome number or it's not a palindrome number. So here we have created a class palindrome number to check whether a number is palindrome or not. Now here we have taken four integer numbers n, num, r and rev. Now the first one n, that is used to accept the number in the variable n. The number will be accepted from the user and it will get stored in the variable name. A number will be accepted from the user and it will be stored in the variable, let's say n. Now in the next line, num equals to n, we are making a copy of that number. We are making a copy of that number in the variable n. Here we are making the copy of the number. Now in the next line, the number, we are executing a while loop. In the while loop, the condition is until the number remains greater than 0. Now inside in the while loop, what we are going to do, we are going to reverse the number. Now this while loop is written for reversing the number, and the condition of the while loop until the number remains greater than 0. So suppose for example we have accepted a number, let's say it is 1, 2 and 1. So yes, 1 to 1 is greater than 0. So definitely it will enter in the while loop and it will extract the last digit, as this one is written that r equals to anyway modular division 10. So when we are modular divide a number by 10, it extract the last digit. So 1 to 1 modular division 10, that means it extract the last digit which is equals to 1, Now in the next line, what we are doing, rev multiplied by 10 plus r. So here rev is initialized to 0, 0 into 10, that means also 0, plus r. The present value of r is equals to 1, just now we have obtained after modular division of 121 by 10. So the present value of rev is equals to 1. So after this operation we have the value in rev which is equals to 1. Now in the next line we are doing that num equals to num by 10. So we are dividing the number by 10. So if we divide a number, let's say 121, it is the number. If we divide this by 10, what we are getting? We are getting 12. If we divide this number, we will get what? We will get 12. So now the number has the value which is equals to 12. Now again the loop will be executed since 12 is greater than 0. Again we are checking that r equals to, since 12 is greater than 0, it will enter in the while loop, and inside in the while loop we are checking that num modular division 10. So num modular division 10 means 12 modular division 10, which is equals to 2, and in the next line rev multiplied by 10 plus r. So what is the value of rev? The previous value of rev, it was 1. 1 multiplied by 10 means 10, plus we are adding the value of r which is right now is 2. So 10 plus 2, which is 12. Again num is divided by 10. Now it becomes 1. 12 divided by 10, so it becomes 1. Now here the value of NUM is right now is 1 greater than 0, so the while loop executed for the last time, and 1 model division 10, the value of R then will be 1 model division 10, that means also 1. Now REV multiplied by 10, the value of REV is 12, multiplied by 10 means 120, plus R, the value of R is 1, so the REV has the value which is equals to 121. Now num by 10, so value of num is 1 and divided by 10, 1 divided by 10 means 0, so it will x out from the for loop, as because the value of num is not greater than 0, it's 0 instead. So when the control just x out of the for loop, while loop, it just check that in the next line whether the value of n and REV are same or not. Well, the number that we have accepted from the user means the value of n is equals to 1 to 1, and after reversing the digit it obtain 1 to 1 also. So n and REV both are equal, so therefore displays that it is a palindrome number. So this kinds of number is called a palindrome number after reversing the number if the digits are remain same at their place. So it is the palindrome number. Let's work with one example of this. Now this one, enter a number. Let's say suppose we are entering the number 12421. It is a palindrome number. If we reverse the digit, then also it remains 12421. Now we are working with another input. Let's say suppose we are working with 12512. So after reversing the digits, that remains changed, it becomes 21521. Well, these two numbers are not same, then it's not a palindrome number. So entering such kind of number, it will display the message that it is not a palindrome number. Our next Java program, we are going to write a Java program to check whether a number is neon or not. So a neon number is the number, suppose we have taken a number from the user and we made a square of that number. So after making the square, if we add the digits of that number, of that squared number, and if it becomes equal to the original number, then we can say that it is a neon number. So first we are going to take the input from the user, then we are making the square of the inputted number, and after that we are going to add the digits. We are going to find the sum of the digits of the squared number, and if it is equals to the original number, then it's a neon number. So this code is written to check whether a number is a neon number or not. So this one here, we have declared some variable integer n, asq equals to 1. Here we are going to store the square of the number. N is the number that we are going to accept it from the user. So in the next line we have accepted the number and we have taken the input in the variable n, and also we have made a square that will be stored in the variable sq. So uh, the square of the n is stored in the variable named sq. Now our next target is to add the digits of the squared number. So we are going to add the digits of the variable sq. So in this next while loop, we are extracting every digit from the sq and we are adding it, and the resultant will be stored in the variable coms sum. For that we have declared it and initialized it to 0. So here in the same logic like the previous one, we are extracting the last digit by using the number model divided by 10, adding it with the sum and dividing the number by 10. So the logic is same, we are extracting the last digit, adding the digit with the variable sum, and we are then dividing the number by 10. so that we are going to add the next digit onwards. So the logic becomes same here, and in the next line we are checking that the number that we have taken from the user as input is equals to the variable SUM or not, means SUM stored the sum of the digits of the squared number. If it is, then it's a neon number, otherwise it's not a neon number. Let's work with one output. So now here we have to enter one number. Suppose we are starting with 9. So 9 square is equals to 81, and the sum of the digits of the square 8 plus 1, which is equals to 9. So it is a neon number. Let's work with another input. So let's work with another input, say for example 6. Now if we made the square of that digit, 6 square is equal to 36, and the sum of the digits will be 6 plus 3 9, which is not equals to the number itself, then it is not a neon number. So this is the logic of the neon number. Now we are moving on to our next program. Our next program is to check whether a number is an Armstrong number or not. So Armstrong number is a positive number, and it's a number if it is equals to the sum of the cube of its digits, then it is an Armstrong number. Such for example 153. Now if we made the individual digits cube of individual digits of that number, so 1 cube, 5 cube and 3 cube, and if we add them also, we will going to get 153. So therefore 153 is an Armstrong number. So this is the code for an Armstrong number. Now here, as you can see that we have declared a variable integer n, a sum equals to 0, except the number from the user. We have declared other variable sum that will store the sum of the cube of their individual digits of the number n. We have made a copy of that variable that we are going to take input from the user. So for that reason we have declared another variable num and r. Okay, so let's accept the number from the user n equals to sc dot next in, that we are going to accept the number from the user, and in the next line we are going to made a copy of the n. So here num equals to n, we are making a copy of the variable n. Now we are executing a while loop. Inside in this while loop, what we are doing, we are extracting every digit of that number that are stored in the variable num. We are making cube and we are adding the digits. So here r equals to num model division 10, that will extract the last digit of the number. Let's say the number is 153, so it will extract the last digit, which is equals to 3. Now in the next line, sum equals to sum plus r into r into r. So here we are making the cube of the remainder. So 3 into 3 into 3, 27, and that 27 will be added with the variable sum. In the next line we are dividing the number by 10, so it becomes from 152 to 15. So again the while loop will be executed since 15 is greater than 0, and now we are extracting the last digit of the number. So 15 mod division 10, that means 5. Now we are making the cube of r, so we are making the cube of 5, and that we are getting added with sum. Now we have previously stored in the variable sum is 27. Now 125 is getting added with 27, that becomes 152. Now at the last, when num divided by 10 again occurs, 15 divided by 10, that means 1. So 1 is still greater than 0, so the while loop will be executed for the last time, and 1 mod division 10, that means also 1, and sum means 152 plus 1 into 1 into 1, 1 cube means also 1, 152 plus 1, that means 153. So when the control will be just reach at the end of the while loop, it just check that whether the value of n and sum are equal or not. Well, the value that are stored in the variable named sum is equals to 153, and we have taken the input also 153. So since both number are equal, then it is an Armstrong number. So let's work with one output. So here we have to enter a number. Let's say we are working with the same number 153. It is an Armstrong number. Now let's work with another input to check whether it's an Armstrong number or not. So suppose here we are going to give a number, let's say 5 to 4. So let's check whether it is an Armstrong number or not. So 5 cube plus 2 cube plus 4 cube is equals to the 524 or not. It's not equals to 524, therefore it's not an Armstrong number. Our next program, we are going to write a Java program to check whether a number is an automorphic number or not. Well, a number is said to be automorphic where the number ends with the same digit. If we made the square of the number, then it ends with the same digit as the number itself. So let's say, for example, suppose the number is 25, and if we made square of 25, that is 625. So the square of that number, it ends with the original number. So in the 625 we have the number 25. Let's say another example, suppose that we have a number 5, and if we made a square, 5 square means 25, and in the squared number which is 25, it ends with the original number, that is equals to 5. So therefore it is an automorphic number. So let's see this Java code. This one is for automorphic number. Of number should be accepted from the user. So here we are taking the variable n. Inside in the n, we are accepting the number from the user. We are making one copy of that m in the variable name temp, and in this step, this one, this while loop is actually written to check how many digits in the number. So C is the counter that will store that how many digits are there in the number actually that we have accepted from the user. So if it is 25, then the value of C, that will be 2. If it is 5, the value of C will be 1. Now in this line we are making the square of the digit of the number, the square of the number that we are doing. So 5 square means 25, 25 square means 625. Now in this line that we are checking that whether the number is ending with, whether the squared number is ending with the original number or not. So for that reason, this one a square number is the squared number. How can we check that? We are modular dividing by the number, and we are making the power of 10. We are modular dividing by the number. If the number has one digit, so we are modular dividing the number by 10. If the number has two digits, then we are modular dividing by the number by 100. If the number has three digits, then we are modular dividing the number by 1000. So in this way we are actually obtaining the n digits of the number. So this C here is useful as because we have to know that how many digits are there in the original number. It can be 1, 2 or 3. Suppose if it is 25, then C will be 2, so we need the last two digits. That's why we are making the we have used here the function pow here. So we are making 10 to the 10 raised to the power 2. If the number that is given by the user has 3 digits, so that will be 10 raised to the power 3. So this part is very important here for extracting the n digits of the number. Now after that we are checking whether the value of r and n are equal or not. So if it is, then it's an automorphic number, otherwise it's not an automorphic number. Now let's work with one input. Let's say for example, first we are working with a positive value 25. Yes, it's an automorphic number. Now in the next case we are going to work with another value. Let's say for example, so another number is 9, and well, 9 square means 81. It's not an automorphic number because the last digit here is 1, which is not equals to 9. So in this way we can check whether a number is an automorphic number or not.
Thanks for watching the video. If you like the video, hit the like button and subscribe to the channel. Press the notification bell icon for regular updates.